Welcome to the Juniper Developer Network and to this introduction to network programmability and innovation with open software. In this short overview video, I'll share some important changes and challenges facing modern network operators and the innovation promises of a new network that's built with far more intelligent and programmable software. Network service providers and the IT staffs that build and run enterprise networks are the primary operators of networks, but any of us can appreciate the challenge and the opportunity ahead because all of us are users. We're living in a digital information age, and what we humans do with technology is evolving. And to support that evolution, we have increasingly complex systems powering arrays of software and different applications that we use. And this is really evident in technology trends like cloud computing. How we access information is also changing in trends like mobility, and the type of information, of course, is becoming richer too, such as video. All that humans do and all that systems do with technology isn't just done in isolation, of course. It's done on networks that connect everything and empower us and those systems to move and share that information. Along with technology, networks have, of course, evolved in some regards, like they've certainly gotten faster and faster in their bandwidths over time. The challenge is that in other regards, we need some major architectural overhauls for them to empower more technology and for them to scale to handle the next wave, so to speak, of the information age. Cloud computing has kicked off this next wave, I think, where massive number of machines, both physical and virtual, need network connectivity and functions, and they need it in a highly dynamic way. This is what is stressing the boundaries of today's networks that are fairly static in their scale and manually provisioned, or at least there's a great amount of work involved to integrate their management and control into other systems. Another frontier to innovation, actually, from the standpoint of applications on the network, is that there's very little ability for them to be aware of and intelligently use or manipulate the network on which they're attached. Apps might be able to guess and probe, but that's about it by and large. On top of this, building network functions has traditionally been a hardware game, where the software on that hardware was fundamentally closed. Unlike the model, of course, for most systems created as open application platforms. See, the closed model has resulted in many challenges. First of all, the software used to run networks is increasingly complex, and operators have little ability to pick and choose modular functions. Second, it restricts the competition and the ability to innovate to those that want to enter into this hardware game. It means you have to bring or sell your own box to even get in the game. That closes the door to researchers and software vendors that could add network services and functions. It closes the door to operators that also want to develop their own customizations and software, and it closes the door to facilitating software-based systems integration. Now, the good news is that Juniper steadfastly adheres to a mission of creating the new network, where we have a track record and a continued vision of solving these challenges head-on, where network programmability, open software platforms, virtualization, and much more, which I'll tell you about, play an important role in improved innovation and economics toward a more intelligent network for the next wave of the information age. Speaking of waves, does this one look familiar to you? I'm sure some of you recognize this as the classic Gartner hype cycle, and we've certainly seen one in 2012, in the buzz of software-defined networking, or SDN for short. The term SDN has been defined in many different ways by various people and organizations, and I'll likely cover SDN in a later video session in this series on its own, but I want to address this right up front here too. While others might have mixed ideas about SDN, thanks to this kind of hype roller coaster that we've been on in 2012, Juniper is not at all confused. We embrace SDN as a component of our software story, and we have long since before it was even known as a buzzword. The reason why is because the goals of a software-defined network align precisely with the goals that Juniper recharted in 2010 when we launched the new network campaign. The overarching goals of the new network and SDN are simple. First, increase innovation, and second, lower the network's total cost of ownership by providing solutions with better capital and operational expense economics. To think about SDN in a productive way, one needs to cut through the hype with focus and clarity. And here are some helpful tips to do that you can use when thinking about networking software. First of all, we can distinguish between virtualized network software and software-defined networking control. Both are useful ideas and can coexist, but they're not exactly the same thing. Virtualized software is about running software in virtual machines. A different major tenet of SDN is decoupling and separating the pieces of network software that may have traditionally run together, namely the management, control, and services planes. Now, these are oversimplified explanations, but you can see how they're different software trends that are better together and valuable to the networking industry if done right. In other words, flexibility in both form and function are desirable. Another point that demonstrates Juniper's focus is our priority on solution contexts, not just individual technologies, that is. It could be valuable and enticing, especially for techies like myself and probably many of you listening as well, to think about technologies bottom up. But top down actually makes more sense because it's better to decide what you need to achieve and then find the right tool for the job rather than having a bunch of tools and trying to build solutions that miss the mark of your ideal. For example, prioritizing a network operator's experience in the context of their own business workflows is ideal. Considering those business applications workflows after the fact means extra glue to translate between the network's workflows and the business applications workflows. If we could begin with the ideal solution and the workflows of the software integration in mind, then application and network integrations will actually become far more simpler and more common actually as well, increasing that desired bidirectional communication between the application and the network infrastructure and making, of course, both more intelligent and dynamic. Having said that, I know you're here to learn about Juniper's network programmability technologies. So I will focus on the technologies here, but we would love to discuss your solution needs with you in person. To achieve the SDN and new network goals for lower costs and higher innovation, there are important sub-strategies inherent in developing our Juno software products, and you can see these reflected in our products today and the evolution of future products. First, we connect and empower innovation by building open application platforms. This means that we use the familiar and successful application platform model, and you're used to seeing this, of course, on your PC and smartphone. While we value innovation, it isn't all about doing it all ourselves. It's about enabling a collective innovation openly and including Juniper and third parties. Second, we empower network operators through choice and creation of new network management, control, and services application software. While traditionally new network functions had to be delivered in more and more hardware systems, new software apps can work even better and facilitate deployment and operations if we can leave out the burden and inefficiencies of more custom hardware integration. Software is also amenable to more flexible pricing models where operators can pay for the use and the value they really get from the features. Third, we embrace network software modularity and a transition to virtualized systems to host software. This strategy allows network operators to leverage the values of virtualization from cloud computing and apply it to their network software. Now, having said that, special purpose network hardware will continue to evolve. Juniper completely discards the idea that forwarding hardware may someday become commoditized. The reason why is because there will always be an evolution where we innovate more easily in software, which is why we embrace software. And as new traffic forwarding and servicing features mature, they can move into new hardware, of course. We can innovate in hardware and software. They're better together. That gives you a glance at what makes us all successful, and I'll absolutely come back into each of these three topics in more detail later in this session and the later sessions of this video series. You're here to learn about Juniper's plans, and as I've said so far in the intro, we are leaders in network innovation with a history and a future to prove it. If you're familiar with Juniper, even from before the time we launched the new network, we categorize our innovation into three pillars, being silicon, systems, and software. Now, of those three, it's certainly software that allows us to reach and service our mission of connecting everything and empowering everyone. That is especially true when you think about how network programmability comes out in the software. Here are a few quick proof points in our history supporting our vision for open software application platforms with an API enabling programmability. You can look back as far as 2005 and 2006 when Juniper started releasing tools to automate and program new apps for the Junos OS. Interns at Juniper used the Junos SDK to implement OpenFlow for our MX series back in 2008, which further enhanced programmability through OpenFlow controllers and that protocol. Today's OpenFlow implementation for Junos OS, by the way, is much more mature, and an open source edition of it's available. Customers and partners have also developed other apps that expose new protocols or add new control, management, and service features. In 2010, we introduced the Junos Space SDK and Junos Space as a new application platform for orchestration, management, design, and analytics across the network, open to new hosted network applications and also controllable through RESTful APIs. In 2011, we built a separate repository of apps and started licensing add-on software modules for the Junos OS and Junos Space. In 2012, we moved into virtualized software in many ways, but with respect to programmability, we've stretched the Junos OS, control, and service plane apps to be able to live in virtual machines running on Junos V App Engine, which can be controlled from Junos OS. Now finally, at the beginning of 2013, we publicly launched our vision for building software-defined networks, or SDNs, together with our partners and our customers. Now we'll see some of these in more detail in later videos of this series. When we're discussing the Juniper programmable and programming products and features, it's useful to have a framework to understand where each technology falls. So we'll use this framework of network layers here. At the top, you have network-aware applications. These are any kinds of applications that need to manipulate or extract information from the network infrastructure. The applications that just blindly use the network are not interested in programming it, obviously, so we're not concerned with them. Network-aware applications could be of any kind, but typically they're owned by the network operator, or else the operator, of course, will put restrictions on who can access and program it. The top bidirectional arrow that you see is network programming at a very high level. It usually happens over RESTful APIs, and a good network orchestration platform in the middle layer, like Junos Space, implements or provides the opportunity to implement and abstract the network details and provide those top-level applications with an API workflow that's a natural fit for them. This is certainly the case with Junos Space, as it is extensible with its Junos Space SDK that I'd mentioned. Usually there is just one network orchestrator or orchestration system, by the way, that the network-aware applications at the top have to deal with. So it's usually logically centralized, like Junos Space is, or if it's not, then guess what? It's going to become much more complex for the applications up at the top to deal with. That's why we want just one. If we move down now, then we get to the networking systems and devices themselves at the bottom. The orchestration platform in the middle usually speaks a number of protocols southbound to enable this. The lower bidirectional arrow represents that protocol communication. Usually that communication from an orchestration point is to hundreds or thousands or maybe more of network devices. When that communication is based on at least some open standards, then the orchestration can manage and control a network of mixed vendor devices. Of course, every network vendor has their own device operating system and its own set of features. Of course, as innovation happens here quickly, there will always be some protocols that are not yet standardized that allow control over new proprietary features. At Juniper, obviously, the network device operating system at the bottom is Junos OS, and it's built as an extensible application platform, also open to applications thanks to the Junos SDK and the API layer that's exposed there. So let's first take a closer look at this bottom layer, and then we'll work our way back up in more detail. So starting off with a closer look at Junos OS and Juniper systems, we can see there are multiple layers here. First off, the bottom three layers form the platform that runs on different hardware depending on the role. The control plane on the routing engine's hardware is usually running on x86 CPUs. The service plane on the service engines runs on special purpose CPUs or NPUs optimized for high network traffic rates. We usually call them NPUs or network processing units for short. Then on the right, we have the virtual plane running Junos V App Engine software, which virtualizes x86 hardware into multiple VMs. The virtual plane is actually not a descriptive role. We're simply using it to differentiate the software on Junos V App Engine. In actuality, it could be both control and probably service network software. Lastly, as you can see at the very bottom, the data plane runs some software too, but at a very low level, to drive the hardware that does the actual packet forwarding in Juniper custom silicon. So where is the programmability? Well, for the native control plane on the routing engine, in two places. In the control plane running the main Junos OS software itself, you can deploy Junos automation scripts and applications built with the Junos SDK. In the legacy service plane running an embedded form of Junos OS, you can deploy traffic servicing plugin applications. And finally, from the Junos OS control plane, one can control Junos V App Engine to deploy VMs for control and traffic servicing applications. And this is the new primary location for the services plane and all of the application services that run there. These apps can run inside any operating system there, like Linux. We'll get into the Junos SDK later as well in more detail. Here we're showing with the arrows that the APIs in the SDK are used by any first or third-party apps, and the APIs come from the first-party apps and mainly from the Junos OS platform itself. Tying this back into the previous picture, you can see some examples here of some northbound protocols that can be consumed by Junos Space, the forthcoming Juniper SDN centralized controller, or other controllers and orchestration systems. The nice thing and unique property of Junos OS being open to development is that you can implement your own here too, or extend some of the existing ones like SNMP, Netconf, and DMI, so that you can control your device level application from a higher level orchestration application, which can be in turn used by a top level network aware application. Zooming back out to this view, let's move up the stack now to the middle layer and see what Juniper offers there. At the topmost level of network orchestration, Juniper's platform is Junos Space. Junos Space is architected with a Java EE application server at its core. Specifically, it's JBoss. It has its own Junos Space SDK that lets developers create their own server-side applications for that server and new client-side applications that get served up from it. Now, Juniper has a growing number of first-party client applications too for all kinds of network management, design, and analytics functions. The clients run in a web browser actually with a standard Junos Space look and feel, and uses HTTP RESTful APIs to communicate back to the server. In a similar way, any other application can use the RESTful APIs to program the network and become so-called network aware. Some examples would include OSS and BSS systems, cloud orchestration systems, mobile and broadband subscriber management systems, and many more domain and industry-specific examples. Today, Juno Space can operate over a network of mixed vendor devices, but it only controls the devices running Junos OS using a protocol called DMI, the Device Management Interface extension of netconf and syslog. While Juniper is looking at future enhancements to the set of southbound protocols from the orchestration platform, today we do have some controller integration examples where user interfaces from Juno Space actually interact with the Space server and other systems like other SDN controllers or OpenFlow controllers or OpenNMS. You may also know that we're building an SDN centralized controller product that you can expect to hear more about in later videos and as that product nears availability. Let's zoom back out to this overview again and recap and expand on the interactions. Down at the bottom, we have our devices running Junos OS. These, along with the endpoints, are what make up the network nodes themselves, and you typically have a mix of different kinds of physical and virtual devices for different control, servicing, and forwarding purposes. In the middle, we have the network orchestration. The opportunity here is to use a single logical orchestrator for some section of the network so that apps can more simply program a network through a single point. I say section of the network, though, because we think about the global interconnections of many networks forming one big one. It's not all managed as one, though. Every operator may have one or more to manage and connect to many others. Now, if you think about realizing the goal of SDN, over time as control moves into controllers and orchestration platforms that are separate from forwarding devices, we will need to have open standardized federated communication between the different orchestrators and controllers and between them so that they can essentially route to each other and cooperate as necessary. It's also widely recognized as a goal for SDN to enable open standardized southbound protocols from the orchestration point to the devices so that the systems at the orchestration point can control and manage devices from multiple vendors that implement the protocols. And then if we go up to the very top, we have apps. Now, apps can mean pretty much anything as a term, so to differentiate here, we want to consider the apps in the context of our Juniper customers, in other words, the network operators. We can further narrow down the set of apps that we care about to those that need to program the network. Let's call those network-aware applications. They probably range a great deal from network service applications processing traffic that could actually enable application-aware networking, all the way to systems like operational and business support systems and other IT information systems. Now, we didn't just cover those three layers, we also covered how they're connected. The bottom two layers are connected by device control and information protocols. We saw many examples of these, of which OpenFlow is one that's gotten a lot of attention of late. Now, it's important to realize that this communication layer down at the bottom is very granular, and by convention we call them protocols rather than APIs. And that's in contrast to the communication between the top two layers, in between the apps and the orchestrators or controllers, where we usually do use the term APIs, and by and large, most orchestration and controller systems provide RESTful APIs, so that any kind of application can call the APIs from anywhere, so long as they're authorized to. Now, there's even one bigger desired difference between the so-called lower-level protocols and the higher-level APIs, and that is that the APIs should be far more abstract and as much as possible conform to the workflows of the applications up top rather than forcing the applications to conform to speaking the language of networks. This is one area where the networking industry, I believe, has an opportunity to still make a lot of progress. In the early days of some controller systems, I've seen a number of attempts get this wrong. Like, for example, there have been many attempts at open source OpenFlow controllers that exposed non-abstract northbound RESTful APIs that get down way into the network primitives in the APIs, and then they stop there without any abstractions. You may have actually guessed that by the fact that the term OpenFlow controller is the term to describe them. That alone can tell you that the system is oriented toward the complexity of the underlying network protocol, in this case OpenFlow, and that technology, instead of marketing to the system's consumer, those apps up at the top. Those apps at the top, they don't care, and they don't even want to care about OpenFlow or the protocols used. They have a desire to do something, and that something is probably not expressed in the same term as network protocols. So one of the more popular examples today of an app up at the top is a cloud management and orchestration system for cloud computing. Those systems don't speak the language of network protocols. They speak in other terms. They speak in terms of tenants, tenant location, address, the need for tenant network isolation, and sometimes interconnection, and hopefully security between them as well. So if the apps up the top need abstract APIs like that, as an example, then how do we build them into the controller and orchestration systems? Well, that depends on the system that you choose. Hopefully the system vendor has an answer. At Juniper, I've already explained to you how our Juno Space product is also an open application platform. It has a freely available SDK, so among other things, any developer can build Juno Space add-on apps that speak in terms of the network-aware apps up at the top. We believe that providing that abstraction to a simple workflow is where there's real value. We can't just build software that translates the network protocols and primitives into REST APIs. That's not compelling. It's of far less value to the applications, and so it's not going to get the developers of those top-level apps using the network in more intelligent ways. Put it this way, Leonardo da Vinci once said, "Simplicity is the ultimate sophistication." And Einstein once said, "If you can't explain it to a 6-year-old, you don't understand it yourself." And we could think of the developers of the apps up at the top as having 6-year-old elementary understanding when it comes to network technology, because they're more concerned with the core of the applications they're building. They don't have time to get a PhD level understanding in modern networking and worry about the networking primitives and learn that language. So, the takeaway in summary is that it's time for the network to become simpler by having more abstractions about it made available, making its sophistication and its intelligence easily accessible. Now at Juniper, this is what we do have in mind, so while we have an internal focus on the technology building blocks, we do that with an understanding and prioritization of the workflows of the top-level applications that we want to enable for our customers. Of course, if you are a customer, the conversations about the future of network software should be solution-oriented, starting with the apps and systems you use that can make better use of the network. That's precisely why Juniper has actually carved up the solution landscape into 5 service provider domains and 4 enterprise domains. If you don't know about those domains, then I highly encourage you to ask your Juniper sales rep, or if you want to find them online, just Google for Juniper New Network Platform Architecture. I know I just said that it's all about getting a solutions perspective from customers, but when we talk to researchers and developers, they like to get into the details of the technology and how it all works. I know I have already covered the details separating out the different layers. I just want to show all in one place how there are so many opportunities for extensibility using the Juniper portfolio of open software platforms. This really busy picture also helps to bring it home how there are indeed so many possibilities. It's important that technologists don't get too caught up in one protocol or one programming methodology. Usually applying several will allow for creating the whole solution in the easiest way possible. Every tool here has its own purpose, thus its own strengths and its own weaknesses too. And that actually reminds me of another quote from Abraham Maslow when he said, "If you only have a hammer, you tend to see every problem as a nail." In other words, if you get stuck on trying to use just one tool for every job, you'll probably end up doing a lot more and a suboptimal job solving your challenge. Remember that there are a plethora of tools at your fingertips, and using the SDKs, you can even build your own protocols and APIs and extend some of the existing ones. When I mentioned that Juniper portfolio of open software platforms, I want to make sure you understand exactly what I mean and how Juniper has challenged and even begun to change the status quo for the networking industry. One of the common concerns of developers is the amount of new investment they have to make in implementing. In other words, how much time do I have to invest in getting started here? That's what they're probably asking themselves. In the traditional models of the past, developers were forced to create the plumbing before they could even start building applications. Certainly that's the case for networks anyways. Much time was spent and wasted in focusing heavily on the foundational aspects rather than the business and the innovation aspects of application development. The goal of our SDKs is to take care of that plumbing and that foundation, at the same time unlock APIs for things that developers previously didn't have access to, like the features of network device, software intelligence, and hardware efficiency. Besides, the application platform software model is very well proven. Every computer and every smartphone you own uses this exact model. It decouples the platform from the apps on top, which reduces the complexity actually on both sides. At the same time, it enables app developers to get to market faster and more efficiently. A nice observation about Juniper's Junos OS software platform for network devices is that there's only a single platform for apps, so developers write once and deploy anywhere. Now, there are already a wide array of hundreds of customers, partners, and researchers developing apps for Junos OS and Junos Space, and even more that are using other avenues of network programmability and automation inherent in our platforms. The goal for our Juniper Developer Network is to connect and inspire developers to innovate on Juniper application platforms. We want to see what you will create. Juniper's vision for the new network is about boosting innovation, and it's also about customer solutions focused from the top down. So as we build apps and connect developers, a focus on apps that drive monetization and lower costs for our customers will determine the success of new software, of course. As I've started out with, we're living in an information age, and the network interconnects systems and the technology that connects us. So there's no shortage of opportunities for apps and an evolution of network software in general when you look across the network landscape. As I've been leaning toward and describing, starting with that customer solution focus is easy when you think in terms of Juniper's new network platform architecture, or in other words, that's what those 5 service provider domains and 4 enterprise network domains are. So learn about those. It's a great way of partitioning your worldview into manageable categories and then building solutions first within them, and then even for the very ambitious, perhaps across them. So how does network programmability and open software impact you? Well, I hope you can answer that much better now for yourself. We're seeing an evolution in network software. The operators and the developers need to come closer together. You operators can probably think of where this could lead to better network management, more automation, and better software feature velocity. Getting beyond those goals, you can start to consider which of your business solutions or top-level apps, as I called them before, need better integration and intelligence from the network to help improve your economics. The possibility for customizing or adding to network software itself enables monetization options for you, and the trend towards network software virtualization enables simpler scalability with lower costs. Now, you developers have an area of expertise that you can apply within the network itself or in apps that can use the network more efficiently. Now more than ever before, you have the opportunity to use the network in a programmable way and extend it where you need to. In the words of our Juniper CTO and founder, it's time to build a new network. So download the tools available to you. Juniper has invested billions in R&D to create the best-in-class platforms on which you can build. With that, I'll bring this introductory session in our series on network programmability and innovation with open software to a close. Thank you for this investment of time. Now it's your turn to combine this knowledge with your own creativity. We're looking forward to hearing from you and having you build the software that powers the new network, where what you can do is limited only by your own imagination.